Okay, cos 2 theta plus 3 equals 3 sine 2 theta. All right. Yes, this one is a bit of a tricky one. They do have a hint there for you. So cos 2 theta, they're giving you a hint in this question, and they're saying to write 3 as 3 cos squared theta plus 3 sine squared theta. I'll tell you why they're doing that. Because isn't 3 equal to 3 times 1? And doesn't 1 equal cos squared theta plus sine squared theta? So if they're asking you to do that, we're probably going to be looking at grouping in pairs. So let's just have a look. If we're thinking of doing that, which way should we write cos 2 theta? I think we should do cos squared theta minus sine squared theta for cos 2 theta. Plus, I'm just going to write the 3 at the moment. We'll do this hint bit later. Equals 3 times, what's the expansion for sine 2 theta? There's only one of them. 3 times 2 sine theta cos theta. So let's say we did this. Cos squared theta minus sine squared theta plus 3 equals 6 sine theta cos theta. So the thing is, we have a bit of a problem because, like, really, what could we factorize out? You can't. Sine theta sort of is just a common factor between those two, and cos is a common factor there, but it's just a bit messy. So the hint here is, and because it's so familiar, they may give you a hint, all right, is to write, here is to write 3 as 3 cos squared theta plus 3 sine squared theta. The actual hint is given, all right, so we'll use that. Cos squared theta minus sine squared theta. We know that 3 is 3 cos squared theta plus sine squared theta. 3 cos squared theta plus 3, sine squared theta equals 6 sine theta cos theta. Okay? Sorry, looking a bit messy. Now, do you have some like terms there? Got to zoom in a bit. So haven't we got 3 plus 1, that's 4 cos squared theta? And haven't we got 3 minus 1, which is plus 2 sine squared theta, equals 6 sine theta cos theta? So here, because of this combined sine cos, it's, even if I took it to the other side, how am I going to factorize it? It's really hard to factorize. So, but whenever you have a combination of cos and sine, you should divide through by cos, the highest power of cos, divide through by cos squared theta, and you will end up with tan. Okay? So what do we get here? We'll get 4 cos squared theta over cos squared theta, plus 2 sine squared theta over cos squared theta, plus 6 sine theta cos theta over cos squared theta. And you're going to see we're going to end up with a quadratic in tan. We could do over 2 cos squared theta. That's good. Do you want to do that? But you could just do by, so let's divide through by 2 cos squared theta. Good suggestion. Which is 2 plus, what do we get? Tan squared theta equals, what do we get? 3 tan theta. Because one of the coses cancels and you get sine on cos. Now that is something we think we can work with. Okay? So that would be tan squared theta minus 3 tan theta equals 2. I even think we can factorize it. So tan theta, plus 2. Plus 2 equals 0. It is plus 2 equals 0 because I've taken over there. So it's tan theta minus 2, isn't it? Tan theta minus 1 equals 0. So we get that tan theta is 2 or tan theta is 1. And we're solving from 0 to 360. Sorry, I didn't write that at the beginning of the question. Now that it's written all in terms of normal thetas, even though these are 2 thetas at the top, you don't have to go and solve for 2 theta because the thing we're solving down here only has thetas. So as long as we're solving between 0 and 360. So this is quadrants 1 and 3, so is that. And you can work out your acute angles. And then you can work out your solutions. So this one's 45. The second one's fine, 45 and 1 and 225, isn't it? 180 plus. Because you can do your little sketches. And the other one you need to work out. Is it 60? I think that one's 63 degrees. So it's 63 degrees 26 minutes for acute angle theta. So therefore theta is 63 degrees 26 minutes and 180 plus, which will be 223 degrees 26 minutes. More examples of trig equations. Just looking at question 3, where we have to solve. We're solving from 0 through to 360. And I'm going to give you something like question 3C, actually no, 3D, where you have to solve cos of 2 theta plus 30 degrees equals negative a half. Now, you haven't seen anything like this yet. Cos of 2 theta plus 30 is negative a half. Now, first I've got to fix up my domain. Normally we see cos theta is negative a half. Or sometimes we've seen cos 2 theta is negative a half. All right, I think I've even shown you shifted domains of cos theta plus 30, but never like this. So you know how theta lies between 0 and 360. What would 2 theta lie between? 0 and 270. And what would, sorry, I shouldn't write that 0 there. What would 2 theta plus 30 lie between? So I'm multiplying by 2. Now I'm adding 30. What do I put here? 30. So 750. In other words, I want the solutions from 30 degrees to 750. Okay. Don't worry about how this looks. All we're interested in is the normal 3 steps. And what's normally the first step? What do I look at? Whether this is positive or negative? And I say, what does that tell me? The quadrants. So I've got quadrants. Which ones? Cos is negative. So cos is negative. Oops, negative. Cos is negative, that says, in quadrants 2 and 3. My acute angle of that. So just write it. Acute angle 2 theta plus 30. Because normally we'll write acute angle 2 theta. Acute angle theta. Acute angle of that. Cos of that is a half. What's that? Yeah. Okay, so now we're doing our quadrants. We know our angle's 60, and this is telling me to go more than 2 times around the circle. But we don't even start at 0, we start at 30. But what we're going to do, if we draw them in, we're not going to have a problem because we're nowhere near 30 degrees. So aren't I in quadrants 2 and 3 with 60 degrees? So I draw them. And I see how do I get there. So my 2 theta plus 30 is, what have we got? First one, 120. Well, that fits. That's good. Keep going. 240. Now, if you're going to go around, we're 360 plus this 120. Do you get it? What's 360 and 120? 480. And if I do that, 360 and 240. Do you get it? What's that? So I can write that one as, sorry, I can write it as 360 plus 120, 360 plus 240. But I don't think I'm going to be going around again. Because that's 1, 2, 3, 4. If I go twice around, that's 720 and 120, that's out. So I don't go further. So I've got 120, 240, 480, and is that 600? All right, no more fit. I need theta. So it's just like solving an equation. That's what 2 theta plus 30 is. What do you get rid of first? Subtract 30 from everything. So 2 theta would be 90, 210, 450, 570. All good? And now what do you do? So, you know, I've shown you the two theta types on their own, and I think I've shown you the theta minus 30 type or theta plus 30 type, I think. But now we've done a combination. But still the steps are the same. You just go cos of that thing. All right, so theta will be divided by 2, which is 45, 105, 225, and 285, which fits all in the domain. All right, so that's how you do those ones. I'll give you one more to do just for practice. And differences, you could. But you're going to end up with sine, cos. You're going to actually make it really complicated. We can try it. Like, we'll have maybe a few minutes. Let's just do the way that I said. So, all right, do you know which quadrants we're in? Sine is positive or negative? Sine is positive in quadrants 1 and 2. Acute angle of this 2 theta minus 90 is 45. How many times around do we go? So we're solving for 0 to 360. And we've got 2 theta, which would be 720. But it's actually not 2 theta. It's 2 theta minus 90. So you've got to subtract 90 from each of these. So we're going from negative 90. What's 720 minus 90? 630. That's where we're going. All right. Now look. So our method is the same. We've got to fix the domain up. Whenever you're not doing the sine of just theta, if you're doing the sine of 2 theta, sine of theta on 2, we've been doing it for weeks. You always change that domain. So we've got 45 degrees in quadrant 1 and 2. Let's start working around. The only thing is, do you notice you've got negative angles? Let's just check the negative one before we start. Negative 90. There's nothing there anyway. Can you see? They're the positive angles. This is the negative direction. Negative 90 is there. There's no angle there. So that's okay. This negative 90 has no effect. Let's go to our positive angles. What's our first one? So the 2 theta minus 90, my first angle is what? 45, and then 135. Let's go around the circle again. 360 and 45 is 405. We're still in. And 360 and 135 is 495, because that's 360 plus 45, and this one was 360 plus 135. And I think if we go twice around and try again, that's already 720. That's too far. So it's those 4. That's what 2 theta minus 90 is those. So what's 2 theta? What do you do to those values? Plus 90 is 135, 225, 495, and 585. And now just divide by 2. 67 and a half. 112 and a half, 247 and a half, 292 and a half degrees. There's solve. Now, it does say hint, sketch it. Sketch it. Now, do we know how to sketch sine of x? Isn't it just this? So that's 180, that's 360. Now, you know where you see, just think of all the work we've done with quadratics. Where is this parabola above the line? Where is sine x above the line? It's just that. That's nice and easy. 0 to 180. You okay with that? 0 less than or equal to, because it is, oh no, less than or equal to, because sine x is above the line, not greater than or equal to. So let's solve both actually. Let's solve sine x is above the line and sine x is greater than or equal to 0. So above the line does not include 0 and 180. Do you know why? Because sine of 0 is 0. It's not greater than 0. But if I asked you to solve sine of x is greater than or equal to 0, you'd have greater than or equal to's here. Does that make sense? Sine x, no, because sine x can't equal 0. You know, because sine of 0 is 0. The solution to that would not be the equal to sign. Does this make sense? And if you were asked for sine x is less than 0, it's 180 to 360. Does that make sense? Cos of 60 is a half. So this one, cos of x is less than or equal to a half. We do a quick sketch of cos, right? A quick one. And we know that's 360. We know that's 180. That's 90. That's 270. And half, see, this is 1 and this is -1, and that's 0. A half is here. That's where a half is. Do we get this? So you know how here we were comparing above the axis, below the x-axis? That's because the x-axis has a y value of 0. What this is, you sketch cos x and you sketch the line y equals a half, and you see where is the cos curve. Are we looking for above or below the line? It's below the line. Where is the cos curve below the line? Well, it's all of here. Now what we need to do is work out those points of intersection A and B. Points A and B, what are they? So I'm going to first solve cos of x is a half. Sorry, and that is, x is what? 60. It's quadrants. You know how we do quadrants, what? Quadrants 1 and 4. It's positive. 60 and, are we good? And 300. You can see it there. 60, 300. So now, if I want to solve cos of x is less than or equal to a half, where is the cos curve below? Between or equal to, do I use equal signs? Yes. 300. Between 60 and 300.